So here is another really common example of a rates functions problem from AP. So on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of t equals 90 plus 45 cosine of t squared over 18, where t is measured in hours from 0 to 8. At the beginning of the workday, the plant has 500 tons of unprocessed gravel. During the hours of operation, which is 0 to 8, the plant processes gravel at a constant rate of 100 tons per hour. So this is going to be really important to figure out what is it that we actually know. So before we even look at the problems, can we identify all the important information? So first, let's see if we can figure out what the rate in is. So it says that unprocessed gravel arrives with this function right here. So this is our rate in. And then we know that, let's see, what else did they give us? At t equals 0, the plant has 500 tons of unprocessed gravel. Now the other part is a little bit trickier to see, but it tells us that the plant processes gravel at a constant rate of 100 tons per hour. So this is actually your rate out. So every hour they're getting rid of 100 tons. It doesn't have a fancy equation like the rate coming in. Okay, and then of course we can look through, we can see all of our units for that one. So let's first talk about what g prime of 5 actually is. So let's calculate it. So we're going to do g prime of 5 equals, well, we're going to need to put this function into our calculator. So let's go back to our calculator. Let's clear out what was in there from the last problem. Make sure you are in radian mode, okay? 90 plus, oops, type it into there, Miss J. 90 plus 45 cosine of x squared over 18. All right, so I want to find g prime of 5, which means I'm going to take a derivative, and I know that a derivative means I need to do math 8. So the derivative of y1 with respect to x at x equals 5. So I get negative 24.588. So let's talk about what this actually means. So first of all, I'm going to look at my units. Since I know that g of t was measured in tons per hour and I just took a derivative, I know that the units here are going to be tons per hour per hour. And I think I would probably write that as tons per hour squared. All right, so now we need to talk about what it actually means. Well, G is the rate at which the unprocessed gravel is arriving at the plant. And we just found out that G prime is this negative 24.588, which must mean that this rate, G prime, or G, excuse me, is decreasing because G prime is negative. So what we're going to say is, let's do it this way. I'm going to pick a different color. We're going to say g prime of 5 equals negative 24.588 tons per hour squared represents that the rate at which gravel is arriving is decreasing by 24.588 tons per hour squared at t equals 5 hours. So I know that that seems a little weird, but we're talking about the rate of the rate. So the rate is actually decreasing, right, by this much. Okay, the other way that we could say it is we could say that this represents that the rate at which the rate of unprocessed gravel arrives at the plant is this amount with this. That gets way more confusing to me. So hopefully this makes sense to you guys. Please, please, please ask if you have questions on it because I know that it can get confusing. But we've talked about when functions are increasing or decreasing and how we look at the first derivative of it. So it should kind of make sense. Okay, part B says find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. So this one only talks about unprocessed gravel that arrives, which means we're going to find out how much actually got there over the whole workday. So from 0 to 8 of G of T dt. And since this is a calculator question, we're just going to use our calculator. So we're going to do math 9 from 0 to 8 of, oops, not that, y1 with respect to x. And so we get 825.551. And this would be tons because we're talking about the amount of gravel. All right, so the amount of unprocessed gravel at the plant, is it increasing or decreasing at time t equals 5? So the first thing we need to first figure out is how fast is it coming in? So step 1 here is going to be what is G of 5? So in order to figure that out, I think I'm going to go to my table and I'm going to go to 5. So I get 98.141. And I know that because this is G, this is measured in tons per hour. If you want, by the way, you could just plug it in yourself. You don't have to go to the table. I just find it easier. The second thing we need to look at is how fast is it going out? Well, they told us that it's going out at a constant rate of 100 tons per hour, which means the rate going out is 100 tons per hour. And now we're going to compare those two values. So if we look at these two things, we can see that the rate that it's going out is greater than the rate that it's coming in, which means the amount of unprocessed gravel is decreasing at time t equals 5 hours. They're taking it out faster than it's being put in. So that means the overall amount of gravel must be decreasing. Okay? So the next part is to what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday. So in order to find a min or a max, we know that we need to look at the first derivative. So I want to first start out by writing out that the amount, which I'm going to call A of t, is equal to the initial, which we know is 500, plus the integral from 0 to t of the rate in, which I'm going to now call g of x, minus the integral from 0 to t of the rate out, which is 100 dx. All right, so all I did was write how we would find the total amount of stuff. So initial plus integral in minus integral out. And in case we want to look at the colors here, this is the initial, this is the integral in, and this is the integral out. So if I were to take the first derivative of that, a prime of t, well, the derivative of 500 would be 0. The derivative of this integral would then be g of t, and the derivative of this integral would then just be 100. So in order to find a min or a max, I need to know when is this amount, g of t minus 100, equal to 0. So I'm going to put this into my calculator and figure that out. So I know that g of t is already plugged into my calculator. So I'm actually just going to go ahead and I'm going to go to g of t and just subtract 100. Now, if I want to know when this function equals 0, it means I'm going to be looking for the x-intercepts. So I'm going to change my window a little bit, and I'm going to go from, I don't know, 0 to 8, because those were the x values they gave me. And for my y values, I've got it from negative 2.5 to 2.5. I think that'll work. So let's see what this looks like. We can see we have an x-intercept right there. So to calculate it, I'm going to go to second, trace, and I'm going to calculate the 0. So if I want to be on the left side, I think I am on the left side right now because I have positive y values. Yeah, there we go. So I can hit enter and then go to the right side and hit enter and tell it to guess, and we get t equals 4.923. Okay, and then from here we need to make an options chart. So we're going to make a chart of t and a of t. We have to include our endpoints, so we know we need 0 to 8, and then we're going to include this point that we just found, which is 4.923. All right, this video is getting really long, so I'm going to leave you guys alone. Your job is going to be to fill in the values for a of t, and then try to write an equation for e. And all you have to do is write the equation. Do not solve anything else for part E. So fill in these 3 values for a of t, write me an equation for part E, and then when you guys are done with that, please take a picture of these 3 pages and upload it to Google Classroom. That is your only assignment from now until the end of spring break, okay? Please reach out to me if you need help, you guys. I am here for you. Oh, and actually, I misspoke. That is not your only assignment before spring break. You will have some practice to do along with this stuff that I will give you on Wednesday. So you'll have one more assignment before spring break, and then you'll have lots of time to process it and ask questions if you need it. All right, I will talk to you guys soon. Reach out to me if you need me.